Hi, my name is Jeffrey Zablocki. In a previous presentation, I went over the private data class design pattern. Now I'm going to talk about a anti-design pattern, and specifically boat anchor. We're going to be going over the definition, how this affects hardware, how it affects software, and for each one we're going to talk about how does it get there, consequences, and prevention that goes along with each. So what is boat anchor? Well, obviously it's a metaphor, but it stands for software or hardware that serves no worthwhile purpose in a system. So even though when you initially think of a design pattern that you're thinking of strictly coding, it's important to note that the boat anchor can affect both hardware and software in a system. So thinking about it from hardware perspective, it's a piece of hardware that gets put into a system that essentially does not get used. So how does it get there? You have a manager or a person who's in a position of authority, and they become convinced of a piece of hardware's usefulness, and they will commit to a product before it has been properly evaluated. And then usually when you get a manager or a person with authority that wants you to use something, they're going to have it implemented, and then all the developers have to try and find a way to make it work. Well, what are the consequences when it doesn't really work or fit into the system that you're trying to fit it into? Well, first thing that comes to mind is you're going to be wasting money. The money on the purchase of the hardware, because ultimately it either doesn't get used or it gets pushed to the side. And then you also have a lot of time that's wasted on acquiring the hardware. And then when you're trying to force a piece of hardware into a system that really doesn't have a place for it, the developers have a constraint imposed upon them, which is going to hinder their developing abilities, which is going to slow progress, it's going to cost time, cost more money. And then it's only going to cause trouble, because the more you try to make it work, like I said, you're eventually probably going to abandon the software, and then you just have a whole wasted effort on integration. So how do you prevent this from coming into play? Well, it's important that managers have their engineers and developers properly and thoroughly evaluate a product before purchasing it. It is well worth the time to put the extra time and money up front to making sure a piece of hardware actually fits into a system that you're going to be using it into. And you should really have a rough plan of how the hardware is going to be used before purchasing it. If you just think to yourself, oh, this could be helpful, but you really don't have a purpose, then you got to think to yourself, is it worth acquiring? And then to build off of that, you got to make sure it's more than just an initial thought of having the hardware. A lot of times when you're in the initial planning stages of a system, you think about and brainstorm several different ideas that could come into play, but ultimately not everything gets included. So you want to make sure that before you go spend a lot of money on hardware, that it's actually going to be used and it wasn't just part of a brainstorming process that got mentioned. So what about software? This is the thing that everybody really thinks about, though, when they're thinking of a design pattern or anti-design pattern, is how does it affect the coding? Well, from the software side of things, you're not purchasing a piece of hardware, but you have pieces of code that are in a system that ended up getting left in there. And really they serve no useful purpose, as mentioned before. Reasons that they can be left in there: a developer may feel that this code's not being used now, but we might need it later and I don't want to delete it. Or they could reference a particular function that has now been removed, and now nothing's calling it. Then the function is left stranded and it's just sitting there. But if people go and look in the code, they see this function and nothing's referencing it, they believe that it still serves a purpose, so they don't take it out because they don't know that nothing's referencing it anymore. And then a lot of times developers will implement modular level variables that get written into pieces of code, but then they're not used. When they're initially planning out how their functions or subroutines are going to work, they may think they may need variables, but then after they're done, they never used all of them, and then they forgot to go clean them back up. So what's the consequences of this? Well, it makes the code hard to read. The code, you can easily double or worse, more the length of pieces of code, because people are leaving unnecessary lines of code written in. And then the longer a piece of software goes and this anti-pattern continues to build, the bigger the code gets, with really essentially a lower percentage of actual useful code. So you got a lot of, quote, noise that's mixed in. It's things that are there, but all it does is distract the developer from what they're actually trying to get at. It makes it hard to maintain, because when developers are looking through code, they see relevant and irrelevant pieces of code, but they don't know how to tell the difference between the two. So usually, if a developer wasn't the one to write it, they'll just leave it alone because they don't want to go back and risk breaking anything that was used. And then it's hard to debug. If you say you come across the bug in a piece of code and you have variable that's getting set and you're not sure how, well, you're going to go through and you're going to step through every piece of code and you're going to try and find where it happens. Well, you'll end up stepping through pieces of code that don't matter. You'll search through and you'll say, well, I'm looking at function A, B, and C, but little do you know that function B is no longer relevant. But you're wasting time going through function B because you don't know it's obsolete. And then you're also vulnerable to error, because a developer could look at a function that has been retired but not removed from the system. They could use it, but they don't know that function's been out of date and not really looked at by anybody in a long amount of time. So how do you prevent it? With proper practice, you can really prevent this boat anchor from making its way into code. It just takes some time and really following good standards. I mean, the biggest thing is, if you're not using the code, remove it. And if you really can't remove it, then you should at least comment it out, because a lot of times with different IDEs, they will use a different color to signify that something's a comment. For example, in Visual Studio, when you comment something out, it makes the text green, and then you know that this is a comment and it's not actual code. There is a downside to this though, because if you just start commenting everything, you could end up with a lot of green code throughout your modules, which then ends up being hard to read again. So if you can, removing it is actually the better option. And then to build off of removing it, a way that this works without people panicking over losing code that they think they might need in the future, is if you can integrate some type of source or version control software into your development environment. So that way when code's been changed, it's checked back in, and then you can go back and look at a module's history and you can see how a function used to be, how it used to be called, and then with the way that different source control software is developing, they have a bunch of tools built in, so you can compare versions. You can see what was added and what was taken out, and then your most recent module only has to have relevant code in it. It doesn't have to have all this extra software that's now useless. To illustrate this, I have two code samples side by side. The one on the left has what we would call boat anchors in it. So if you're going through, the function's called complicated function, and that's just to simulate that, this could really be a lot worse than it is now. This is only a handful of lines of code, but if you think about it on a large scale, it could really cause problems. So this function is going to end up returning whatever is saved into the variable A, and I have everything prefixed with DBL to signify the double type that it is. So on the right side, I went ahead and I removed all unnecessary pieces of code. So even though calculations were being done with some variables F and C on the left-hand side, in theory, this company's function retired the variables B, C, D, and F. They're no longer useful, and some developer just decided to leave those in there because they wanted to know what functionality or what calculations they used to do on those variables. But on the right, I can go ahead, remove everything out, and you can see it's a lot easier to read, and it's a lot easier to see what is relevant to the problem. So if you think about this and extrapolate it to a much more complicated scenario where we have thousands of lines of code and several hundred functions, then the boat anchors will really make a huge difference in whether or not it's easy to understand the code. So overall, you can see that the boat anchors, it can be software or it can be hardware, but essentially it's something that sits in the system that serves no purpose. It ends up costing you both time and money. time is money, and the more time you waste, the more money you're losing. And then a hardware boat anchor can be prevented with proper preparation. Manager really needs to take the time to think about whether or not hardware is worth the purchase. Software can be prevented by following good programming practices, implementing source control. Get rid of the things that are not being used so that especially in multi-developer environments, other developers are not being confused. So here's a list of references that I looked at to get some information from, along with my personal experiences with this anti-design pattern. And if you have any questions, feel free to comment in the thread. Thank you for your time.